Hello from Stockholm, where I will be speaking to 5 of this year's Nobel Laureates. For the first time on TV, from their homes and offices around the world, the laureates will discuss how science is responding to the global pandemic, how to tackle food poverty, and our fascination with black holes. Welcome to Nobel Minds. Hello and welcome to Nobel Minds from Stockholm, the capital of the Nobel Prize. As with much else during the corona pandemic, this year's discussion will differ somewhat from previous programs. We have gathered 5 laureates from different categories by video link, and we will be focusing on their groundbreaking work and contributions to mankind within science, peace, and economics. In San Francisco, we have Michael Houghton, one of the laureates in medicine or physiology. Emmanuelle Charpentier is with us from Berlin. She's been awarded half of the Nobel Prize in chemistry. One of the physics laureates, Andrea Ghez, is joining us from Los Angeles. And in Rome, we have Valerie Gore, Assistant Executive Director of the World Food Programme. One of the upsides of the situation is that you can join us today. Normally, the Peace Prize laureate is in Oslo, but obviously not this year. Paul Milgram, one of the economics laureates, is with us from south of San Francisco. Welcome to you all and congratulations.
Thank you.
Thank you.
Michael Houghton, I know that you from the beginning weren't sure you wanted to get into biology. You were more into physics. But then when you were 17, something happened. Could you please tell us about that?
Yeah, I was very interested in physics, but I wasn't very good at it. And so at 17, I was qualified to go to college to study physics or math or chemistry. But I wasn't sure I wanted to do that. So I took a week out of my life to go to the local library in England where I was living. And they had a careers office and all the careers from A to Z. And when I got to M, microbiology, I read about Louis Pasteur's life and how his life was affected personally by the tragic loss of his daughter and how he dedicated his life to microbiology. To understand it and prevent it happening to others. So that was a big turning point in my life. And then when the structure of DNA was elucidated by Watson and Crick and Wilkins, that really fascinated me as well. So yeah, I was dedicated to molecular medicine probably around the age of 17.
Fascinating. What about the rest of you? Was there a certain moment in time that sort of defined your choice of career?
I remember that when I was 11, 12 years old, at least it's what my mother remembers, is that I came back from school telling her that one day I will be working at the Pasteur Institute. And when later on I chose a lab at the Pasteur Institute for my master studies, she reminded me that, yes, I was obviously interested in working at the Pasteur Institute for a while. But I guess, I don't know, I experienced different waves. I remember that around 15, this was a mixture of wanting to be a detective and being quite fascinated by people spending their life in monasteries. Now I understand what it means, because when you're a researcher, you need to spend your life in a way like in a monastery, and in a way you're a detective, because you have some questions, puzzles to go through. So yeah.
Paul Milgram, what made you choose economic science?
Well, I sort of stumbled into it. I guess as an undergraduate, I studied mathematics. I had a terrible physics teacher who drove me out of physics in my first year in physics. So So I studied mathematics, and then I went to work in industry and got bored there and went intending to get an MBA and landed at Stanford, where I was studying for an MBA, totally different kind of career. But I was interested in research questions, and I read this paper by William Vickery about auctions, and I was totally fascinated by the idea that you could use mathematics to model human behavior and come to understand, how a human institution would perform. And I just got drawn into it. And so I switched into a doctoral program. I was sort of recruited, actually, by the faculty to switch programs. And
they actually told you were at the wrong place, right?
They told me that I was in the wrong program. I was in an MBA program, and I kept talking about, the fundamentals rather than the business problems.
Andrea Ghez, I heard that at the age of 4, when you saw the moon landing, you said, I want to be the first woman on the moon. Have you since then known that you wanted to work in this field?
Well, it's actually no. Hindsight's always 20/20 in terms of understanding how we arrived at where we are. So at the same time that the moon landing definitely inspired me to think about the universe, and in particular to think about questions of space and time, which really kept me up at night. I also wanted to become a ballerina when I grew up. But by the time I was in high school, I understood that I really had a passion for math and science and an aptitude for it. And I went to college actually as a math major. I think it's interesting in terms of these conversations in terms of what fields we went into and then were attracted to, because I soon found out that math was far more esoteric than what really pulled me. And it was physics that really spoke the language that I was interested in terms of understanding these concepts of the universe. So that is how I got there.
Valerie Gore, when did you realize what you wanted to work with?
Well, I think I was still finding myself, but in my mid-20s, early in my career, I was working for the U.S. Agency for International Development, and I had the chance to go to Somalia as part of a relief airlift mission to bring food to the country that was having a major hunger crisis. And while I was there, it evolved into a famine, and which was, so devastating to see. But once we were able to access people with food, medicine, clean water, there was such an immediate turnaround in the situation. And from that moment on, I was hooked. This is what I want to do.
Nobel Minds is an opportunity for you to talk to each other about your work, about your research. And we will start off with the prize in medicine. Professor Michael Houghton, you are on the verge of starting clinical trials for a vaccine for the hepatitis C virus. Let's have a look at the work for which you and your fellow laureates have been awarded. More than 70 million people are infected with hepatitis C worldwide, a virus that causes diseases such as cirrhosis and liver cancer, killing 400,000 people a year. The work of this year's medicine laureates has transformed the understanding of this blood-transmitted virus, which patients can be silently infected with for years before serious complications emerge. Before their findings, having a transfusion was a bit like Russian roulette.
We actually found that we could decrease the incidence merely by use commercial blood donors. But that was a big finding. It became clear that the cases were not A and not B, and that meant there was something else. Turned out they found a new virus. And then we spent the next decade trying to figure out what was this new agent.
You can study in biochemical assays enzymes or proteins that the virus needs, but in order to understand if a compound that might be inhibiting those functions actually is going to work, you really need to find out, does it get into a cell? Because that really sort of is important for developing the toolbox that one needs to not only study the virus, but also to begin to screen for or evaluate drugs against the virus.
Since then, we've seen tremendous advancement in our understanding of the virus, to the point that we're now talking about the possibility of eradicating it worldwide. There are, unfortunately very expensive, antiviral drugs which can, for the first time, treat and cure the infection. And on the horizon, there is also the possibility of a vaccine. As we heard, it is possible to eradicate hepatitis C. What would that mean to you?
Obviously it would mean a great step forward and great satisfaction. I've been working on Hep C for so long, nearly 40 years. So I think it will take another 5 to 7 years before we have a vaccine approved for human use. And then I think Hep C will no longer be the threat that it is still today.
But how do you feel about the fact that your vaccine takes so much longer compared to the the corona vaccines? Isn't that somehow frustrating?
Yeah, it is. And, I think COVID, despite being so tragic, has also taught us how to do things better in the future. And I think by incorporating some of these new technologies, specifically the RNA technology, and as well as the adeno-based vaccine technology, we can speed it up. And I think also we've all learned, academics and the corporate, private world and regulators and governments, if we work together, we can do things much quicker.
We are now going to move on to the chemistry prize. The two laureates made an unexpected discovery while doing basic research. When Emmanuelle Charpentier and Jennifer Doudna started investigating the immune system of a Streptococcus bacterium, one idea was that they could perhaps develop a new form of antibiotic. Instead, they discovered a molecular tool, the genetic scissors, that can be used to make precise incisions in genetic material, a discovery of untold possibility. Using the genetic scissors, researchers can, in principle, make cuts in whichever genome they wish and rewrite the code of life.
It's kind of unbelievable how fast things have changed. I mean, labs now around the world are using CRISPR technology for genome editing. Already we've seen the results of clinical trials that are testing its ability to correct disease-causing mutations. It's just been extraordinary. I mean, the pace at which this technology was adopted worldwide was truly unprecedented, I would say.
Biochemists and cell biologists can now easily investigate the functions of different genes and their possible role in the progression of disease. In plant breeding, researchers can give plants specific characteristics, such as the ability to withstand drought in a warmer climate, or resist insects and pests that would otherwise have to be dealt with using pesticides. In medicine, this gene editor is contributing to new cancer therapies and the first studies attempting to cure inherited diseases, such as Huntington's disease and muscular dystrophy. Professor Emmanuelle Charpentier, before you and Jennifer Doudna made your discovery, the genetic scissors, also known as CRISPR-Cas9, did you ever imagine something like this tool would be possible?
It's true that when you come to discover such a mechanism and that you understand that it's going to have the impact that it has, it's a huge moment.
What kind of fields, what kind of diseases do you hope that it can be used for in the future?
It is actually currently developed as a gene medicine that has shown already some success to treat patients with certain blood disorders, such as sickle cell anemia or beta thalassemia, by combining gene editing by CRISPR and cell therapy. And it has also some impact in curing certain types of cancer, such as leukemia, through the combination of gene therapy and immunotherapy. So one sees already some results directly in medicine.
The possibilities of CRISPR are tremendous. But there is also an ethical discussion. With the CRISPR, we might in the future be able to design a baby with, for example, the gender of your choice. How concerned are you about that fact?
For sure, the technologies are evolving extremely fast. And it is possible that in the future, one will see CRISPR being able to be applied in the human germline to modify more than one gene. And here, for sure, one can worry that the technology may be used for wrong purposes. The only thing I can say is that you have a number of scientists working together, and not only scientists, but other players, in ethical considerations working together to make sure that the technology is not used for unwanted purposes that will be human enhancement or human transformation.
And, just wanted to comment, as Dr. Charpentier described, it can be applied to genetic disease. It can also, as she pointed out, be applied for infectious disease. Hep C we can cure with antivirals. We cannot cure HIV and hepatitis B, but maybe with the technology she's developed with her colleague can be used to actually cure HIV patients and hepatitis B infected patients.
Andrea, I guess you have said that things are most interesting when they're not working. Can you please elaborate on that?
Well, in my research, technology has played such an important part, giving us insight or ways of viewing things that we hadn't been able to see before. And while you go into the field trying to answer a certain question, often the new technology gives you insight into new questions that you should have asked that you didn't realize you should, that the universe works in different ways. And for me, as a scientist, it's really exciting when that happens, when things don't behave the way you had anticipated. It's really an opportunity to think much more deeply about what's actually going on.
That's how it is. Often experiments that you think will work and yield some information don't. And sometimes experiments that you were almost talking yourself out of doing become the most important ones. So I try to convey that to the students and the trainees, that you can't predict what's going to happen in science. You just ask some questions, and it's surprising how really it progresses. It really is.
Professor Paul Milgram, what's your message to the students?
Well, it's the same thing I think we've been hearing. You try to ask questions whose answers, if you get them right, you think will be important. But then as you explore, new questions come up along the way, and you just follow them, and you understand that some of your conjectures are going to be wrong, and you keep exploring what's interesting, what's surprising, and hope that you find something important.
I actually tell my younger scientific colleagues that if somebody's telling you it can't be done, that means you're on the right track. keep going. That's a good sign when people tell you that.
Oh, yes. I think, one of the things I've heard from, that I hear from everybody in this group is, you really have to have the courage of your convictions. Other people don't see what you see as potential. You just keep plugging away in the directions you think are the right ones and try to convince other people to come along.
Let's now take a look at the big picture. This year's prize in physics is about our universe and black holes. For amateurs, trying to grasp the idea of a black hole is mind-boggling. What is it? Something incomprehensibly heavy and impossible to observe. For astrophysicists, it provides proof of the accuracy of the general theory of relativity. And for all of us, it is what makes, for example, GPS navigation possible. This year's laureates share the Nobel Prize in Physics for their discoveries about one of the most exotic phenomena in the universe.
It took years, I would say probably a decade, before people eventually accepted that black holes maybe were really there.
Roger Penrose used mathematical methods to reinterpret general relativity, to prove that black holes can be formed from dying stars. Using the world's largest telescopes, Andrea Ghez and Reinhard Genzel developed methods to be able to see all the way to the center of the Milky Way, through the huge clouds of interstellar gas and dust. They refined new techniques to compensate for distortions caused by the Earth's atmosphere. In the Milky Way, they found convincing evidence of a supermassive black hole in the area of Sagittarius. Professor Andrea Ghez, you spent 25 years trying to find a way to observe black holes in the center of the Milky Way. I'm very, very impressed by your patience. What kept you going?
Well, it's interesting. We didn't set out to do a project for 25 years. In fact, we envisioned only the first stage of what became a 25-year project. And so I think what kept me going is both a fundamental curiosity about black holes, and also the fact that as the project went on and technology developed, there was more and more to ask, and the realization, in fact, that we could do more. So each step sort of led to the next. So I think it was both curiosity and tremendous opportunity in terms of what was happening with the work.
Because of your discovery, GPS navigation is possible, as we've heard. But aside from that, why is it important for us to know that there are black holes out there?
Well, black holes are so interesting. They represent a fundamental breakdown in our understanding of physics. So in some sense, they point the way to deeper insight in terms of our description of the physical world. So from a pure physics or gravitational physics perspective, black holes are the path forward for our deeper understanding of gravity. And then we also think that black holes play a fundamental role, the supermassive ones, as opposed to the smaller stellar mass black holes, play a fundamental role in the formation and evolution of galaxies. So if we want to understand the way in which the universe evolves, these are just absolutely key components.
I think it's amazing the work Andrea and colleagues have done. It sort of makes you realize we live in a surreal world, isn't it, really? We are concerned with everyday life and our careers and getting jobs and so forth. But when you actually get deep down to it, we don't understand really what we are and why we are. So I think, the black hole work emphasizes that more and more. So it's kind of has a deep impact on human psychology, I think. So we're living in a mystery. In a way, I find that actually reassuring. I kind of like living in a mystery. So, yeah, wonderful work.
Emmanuel Charpentier, how fascinated are you by space, the universe?
I think it's the same that what was mentioned. We feel that we are very, very tiny and that, the world is so huge. Now, when I look at stars, it's like I look at it's like I look at little microbes shining. This is always what I see. I mean, I actually, it's looking at the sky it's reflecting on the humanity, as it was said. Why are we here? For which purpose are we on this planet?
Andrea Ghez, what is it like to work in a field when the public is so engaged?
I think it's actually part of what makes astronomy and astrophysics so important, that public engagement. I often think of this field as the gateway science. It's an important field for engaging the public and young students in science and technology. We live in such a technical world, and generally there's such phobia around science and technology. I think it's a useful field for engaging and talking about the broader concept of science and technology.
When you first presented your project, they said no.
was actually quite surprised because it seemed so obvious to me that this was an interesting project to do, and in fact had done so much work to prepare for it. I think, in a sense, scientists are generally quite conservative. So in a sense, discovery comes from taking risks. So it was key to convince people that the technology would work and it was worth investing the telescope time in the project. So it was a little bit of a campaign to convince people that the idea was robust.
We are now going to focus on the next award, this year's Peace Prize. The World Food Programme, the world's largest humanitarian organization, is among the first on the scene in an emergency. The organization provides food and other assistance to the victims of conflict, drought, floods, earthquakes, and hurricanes, as well as pandemics such as the current.
Right now, Afghanistan is facing 3 Cs: conflict, climate change, and COVID-19. We've seen an upsurge in fighting that's forced people to move, and we're worried that that is going to deteriorate even further.
At the same time, the World Food Programme focuses on sustainable development, providing governments with support to manage food security in the long term. Each day, the organization has 5,600 trucks, 30 ships, and nearly 100 planes on the move, delivering food and other assistance to those in most need.
As you can see behind me here, it's really looking very chaotic, but this is the kind of situation in which we are right now. As a humanitarian organization, WFP really has to play a very important role here by providing food for people who are here in this camp, and also water and also fuel.
The WFP is working to save and change the lives of 100 million people in 88 countries. Each night, nearly 700 million people go to bed on an empty stomach. The eradication of hunger has been one of the United Nations Sustainable Development Goals since 2015. The World Food Programme is working towards reaching a world with zero hunger by 2030. Valerie Gore, the work of the WFP, how does it contribute to peace?
Well, there can be no peace without addressing hunger. And there's no way that we can end hunger without ensuring peace. Conflict is what's driving hunger up in the world. And so the World Food Programme works to eradicate hunger. And we have to face the fact that there are millions of people displaced by conflict, separated from their livelihoods, who need urgent food assistance. And we want to make investments in their lives so that they can be more self-reliant, grow nutritious foods, take care of their own well-being and that of their children. So these two things really come together: conflict and hunger, peace and food security. And we're really working to ensure that we can end hunger, and we're not on track to doing that.
But would you say that this goal is achievable?
It's definitely achievable. This isn't one where we need a new invention or we need a vaccine. And nutritious food is the vaccine for hunger. And so the fact that we're facing a hunger pandemic, the fact that 4 countries are facing devastating famine in the coming months and year is really a representative of the failure of political systems to ensure that all people have access to the nutritious food they need to live healthy and productive lives. So we need the political will, we need resources in order to support populations, and we need to improve food systems to ensure that they deliver for all.
I've noticed with COVID, the expense of COVID, and countries are getting into deficit, and some of them are reducing their overseas aid. How much is that a factor in your objectives for ending hunger?
Well, that's something that we've been very concerned about. And thankfully this year, The governments that support us have been generous, and we've been able to reach our targets, but we still lack billions of dollars in order to address the growing need. And there's this sense that there's domestic budgets that are under strain, there's fiscal stimulus packages that are absolutely necessary. But while COVID affects everybody, it's the most vulnerable people in the most fragile nations that are affected most of all.
To help others to make a difference is a driving force for many people. Michael Houghton, I know that you've had letters from patients who have been cured of hepatitis C. Can you tell us a bit about that?
Well, yes, especially from mothers of children. Hemophiliacs have been very vulnerable to hep C infection. So to get letters knowing that you've made a difference in their lives is obviously it's very moving. Conversely, I was contacted very recently, actually just 2 days ago, by someone whose loved one passed away from hep C. So it works both ways, The quicker we work, the more lives we save.
Emmanuel Charpentier, I know you have also received messages from patients or parents of children affected with the genetic disorders. They put their hope in you.
One is always emotional when you read messages from patients because they are desperate and, they offer themselves to to any kind of treatment available, even in development. So surely it's as Michael mentioned, you have a large number of diseases that are still to be eradicated, and it's a huge challenge. And as Valerie mentioned, everything is linked. You have the issue of conflicts, you have the challenges of climate change and of fighting diseases, of hunger. Everything is linked.
I don't often get letters from people about how an economic invention has saved a life, and I certainly respect my colleagues and wish I could have that kind of impact. But the kinds of impact we can have that are relevant for life-saving, among many other things, when we think about resource allocation, which is what economists think about, when we think about, for example, the new COVID vaccines that are coming out, there are efficiency issues in distributing the vaccine that also will increase the number of lives saved. Shipping the right vaccines at the right time to the right places is also going to save lives. And the role that we have, and as economists in helping design distribution and helping when we have a variety of priorities and helping take account of those priorities to make sure that the distribution satisfies those, that will also help save lives. Not in the primary way that my scientific colleagues here have done, which I honor and respect, but still in very practical ways. Getting the distribution right is very important.
We are now going to look at the prize for economic science, and the prize deals with auctions. Traditional farm auctions, someone making a sale on the internet, the European Union's auction of emission allowances to mitigate global warming. Auctions are becoming increasingly common and increasingly complicated. Paul Milgram and Robert Wilson have not just clarified how auctions work and why bidders behave in a certain way. They have also used their discoveries to invent entirely new auction formats for complex situations where existing auction formats cannot be applied.
Well, my experience was so much with the oil industry, where it was so prominent, because there's enormous uncertainty in the valuation of these tracts. Their estimates of the values are very imperfect. You'll drill, and then you'll find out that it's either dry or not. That's the first part of it. The second part is that their estimates of the value of the hydrocarbons if it's not empty, if it's not dry, are very imperfect. That's the second part. I mean, there's a third part, which is that your estimates of the future price of oil are very imperfect and very highly volatile, so you're facing that.
Milgram and Wilson used and developed game theory to analyze how different actors behave strategically when they each have access to different information. Their best-known contribution is the auction they designed for the first time the US authorities sold permits for radio frequencies and wireless communication to telecom operators. This model has brought billions of dollars in revenue to governments instead of to lobbying firms or frequency speculators. Since then, auctions have been increasingly used in the distribution of complex public utilities, such as electricity and natural resources. In the future, they might be used for life-saving benefits, such as the safe international exchange of transplant organs. Professor Paul Milgram, I know you yourself have bought property, a house in California, an apartment here in Stockholm, where you had to participate in a bidding procedure. Have you ever felt, ooh, I might have paid too much?
Well, yes, of course. When we bought our house in California, actually, emotions come in a lot in these simple auctions that consumers engage in. And my wife and I had been looking for a house for a long time, and we found one house. It was the only house she liked among all the houses we looked at. And I thought, I really have to buy that house. And I'm sure I paid too much. Although, we've lived there now for, almost 20 years, and we've enjoyed it. So I guess I don't regret that too much. I wanted to offer one other comment that I think one of the things that distinguishes the Economics Prize this year is it's, in many respects, the work that the Nobel Committee decided to honor was more engineering work than scientific work. It's true we've done some, fundamental research in game theory and so on, but these designs were really engineering how markets work. It's less about fundamental discoveries and more about seeing, how we could put them to work to improve resource allocation. In your little video, you mentioned the kidney exchange, which is also matching kidneys to donors is an issue that's not mostly about money. It's mostly about getting the matching right. And so when people think about auctions, they think mostly about cash. But market design isn't primarily about cash. It's primarily about getting the right resources into the right places.
We've talked about COVID-19. And when the COVID-19 vaccines are distributed, that will be a typical allocation procedure. How complicated will the distribution around the world be, would you say?
Well, so first of all, you have to understand why it's not simple. The vaccines are not all the same. Some of them require more infrastructure than others to be distributed well, and the timing which vaccines are available when in different places is going to be a critical issue. The question of making sure that this isn't just for rich people. We're not running an auction where we say, gee, those who can afford to be protected are the ones protected. I think that fortunately that that countries are taking these things into account. So these complexities are real. We're addressing them, and hopefully we'll do a good job of getting vaccine to the people who need them.
Michael Houghton, from what I understand to be a fact, there will be new pandemics. What can we learn, would you say, from the tragic situation we face right now?
Yeah, I think there's many lessons we must learn from COVID. I think the first one is governments around the world need to spend more money funding infectious disease research, both basic and translational. I think number two, we've learned working together, everybody at all levels of society and internationally, really helps progress. I think a very sobering lesson is that if we had made vaccine against the SARS strain that was circulating in 2003 and stockpiled it, we would have prevented much of the disease and fatality of COVID. So we must start stockpiling vaccines, I believe.
I totally agree with Michael, and as a matter of fact, I focused all my research on the understanding of bacterial infectious diseases, and it was always a struggle to remain in this field of research, and I had to go from one country to another one to find the way to stay in this research. Actually, I have two concerns. I mean, we talked about the challenges of global warming, hunger, fighting diseases. There is also the healthcare system. I think this pandemic has shown that the healthcare system needs major improvement and also funding. But having said this, I'm also concerned, and I'm sure that Michael will agree with me, I'm concerned with the fact that how science works, how the scientists are anyway judged to be able to go on with our career. And the way we are judged impacts also a lot different types of areas of research that are forgotten along the way. You have some fashionable subjects of research, and microbiology is always the least fashionable one. So I'm concerned that we lose experts in the long run who really understand bacteria and viruses and can cope with the future challenge of pandemics. Since it's inevitable, we will always face pandemics.
Well, I think that's a really good point. Many years ago, people would have said studying bacterial viruses is not as going to be as profitable as looking at mammalian viruses, for example. And Emmanuelle and her colleagues have shown that how valuable that is going to be for humans. So it's a very good point. Some of these very specialized areas of research, you can be surprised how much impact they can have on humans. And so I think she's exactly right. We should be broad in our funding. We should fund curiosity-driven research for sure, even in areas where you think there might not be human equivalents. At the same time, I think you do want more funding for areas that you think might be relevant to human health. So it's a mixture, If you want to score the bullseye on a dartboard, it will help you to throw at least towards the wall that has the dartboard. But on the other hand, the wall behind you, as I think Emmanuelle has shown, you can get surprising consequences from basic research in very exotic specialty areas.
Andrea Ghez, you earlier said that every challenge is an opportunity, even a pandemic. What do you tell your students when obstacles and problems arise?
I think it's such an important part of their development, actually, is to figure out how to deal with challenges. We all face challenges in our professional and our personal lives, and this is an enormous challenge worldwide. And to think about how they can make differences on both small scales and large scales.
Professor Paul Milgram, in these extraordinary times, what do you want to give your students?
Well, I want to keep them motivated toward working on important problems. I think we've only begun to talk about them. Within economics, there are others that we care a great deal about too. We care about income distribution and poverty. We care about food resources, the importance of which we've already heard. We care about helping the economy to operate more efficiently, so there are more resources available for all these priorities we have, from climate change to poverty to everything else. And some of that is about fundamental research, is about coming to understand the mechanisms so that we can make policies and intervene effectively. And some of it is about the kind of engineering that I was talking about before, which was taking that knowledge and seeing how we can apply it in the complex world we live in.
I think it's important to, and I think this program is doing exactly that. I think it's important for young students to understand and feel the enormous depth of what it means to be human, our collective intellect, our collective science, our collective knowledge, the world about us. And I think the program you're putting on today can really help young people understand that. We're all part of this incredible, rich tapestry. Yes, we have disasters, we have tragedies like COVID, but I think the enrichment you can get from science and intellect and inquiry is incredibly meaningful, and it defines us as humans, doesn't it?
Valerie Gore, working with poverty, with conflicts, and now with the pandemic, how do you keep your hope up?
Well, I'm inspired by the people who we reach, the people who we serve. Their resilience in the face of just a tremendous amount of adversity is what keeps me hopeful, and it makes me just want to do more and want to do better. So I'm generally really hopeful about the future, but we need to do better.
Well, that brings us to the end of this Nobel Minds discussion. Thank you, all the laureates, for being with us.
Thank you.
It's been so interesting talking to all of you.
Thank you.
Thank you so much. It's been great.
We've really enjoyed it. Thank you so much.
Thank you for watching Nobel Minds. Goodbye.